Good day, students. In continuation with chapter 1, that is real number, our topic is irrational numbers. Now students, in irrational number, we have already done irrational numbers in class 9th. So we again come back to irrational number in class 10th. In this class, we will prove how we can say that a given number is irrational number. We are calling it irrational numbers. Now, irrational numbers are those numbers which cannot be expressed in the form A upon B. We cannot express in A upon B, where A and B are integers and B is not equal to 0. So again I am recalling it. Irrational numbers are those numbers which cannot be expressed in A upon B form, where A and B are integers and B is not equal to 0. Now students, irrational numbers, if we represent them in terms of decimal representation, then we can write that irrational numbers are non-terminating and non-recurring decimals. And some examples are square root of non-square numbers, cube root of non-cube numbers are irrational number. Now here one more example, pi is also irrational number. Now students, I repeat here again, irrational numbers are those numbers which cannot be expressed in A upon B form, where A and B are integers and B is not equal to 0. If we represent them in decimal form, then they are non-terminating and non-reoccurring decimals. And more examples of irrational numbers are square root of non-square numbers, cube root of non-cube numbers, and pi is also irrational number. Now we will solve some example. Now student, we will solve this example. The question is, show that root 2 is irrational. Now solution. Now here we have to prove root 2 is irrational. So in solution we will start with the contrary. Contrary means the opposite. Here we will consider root 2 is rational. We will consider the opposite. So we will start. Let us assume to the contrary, that root 2 is rational, and let its simplest form be A upon B. Then A and B are integers having no common factor other than 1 and b is not equal to 0. Now root 2 will be equal to a upon b. Now here we will square the both side. We are going to write squaring both side. It will be 2 is equal to a square upon b square. Now we will cross multiply it. So we are going to write 2b square is equal to a square. Now this we will consider as equation 1. Now here we will write, because it becomes the multiple, here we will write 2 divides a square. Therefore 2 divide a also. Now students, this question is important because this question is repeated many times in board exam. So here I am repeating it again. We have to prove that, show that root 2 is irrational. So we will consider the contrary. That means root 2 is rational. So root 2 is equal to, we will consider root 2 is equal to a upon b. Squaring both side, 2 is equal to a square upon b square. Here we will cross multiply, it will become 2b square is equal to a square. We will consider this as equation 1. Now this becomes the multiple, so we are going to write 2 divides a square. Therefore, if 2 divides a square, that means 2 is going to divide a also. Now after this we have to assign another variable to it. We are going to write 2c is equal to a. Now we are going to putting a is equal to 2c in equation 1. Your equation 1 was this, 2b square is equal to a square. Now we have to put 2c is equal to a in this equation. So this equation will become 2b square is equal to 2c whole square. It will become 2b square is equal to 4c square. We will cancel out this. Now the result will be b square is equal to 2c square. Now see here, it again becomes the multiple of c square. So we are going to write here 2 divides b square. Therefore 2 divides b. Now student, see, 2 divides a square, 2 divide a. And when we put the another variable 2c is equal to a, we got the result b square is equal to 2c square, which shows that 2 divides b square also and 2 divides b also. Thus 2 is a common factor of a and b. But this contradicts to the fact that A and B have no common factor other than 1. So therefore root 2 is irrational number. So students, earlier I have said in this video that in this class we will think about, or we are going to prove how we can say that given number is irrational number. So if you come across any type of this question, similar question, you have to do the solution same as we have done in this question. If it be root 2, root 3, root 5, root 11, any kind of solution, we have to follow the same procedure. Now student, this is another type of question. Show that 5 minus root 3 is irrational. Now the solution will be, let us assume to the contrary that 5 minus root 3 is rational. That is, we can find co-prime A and B. B is not equal to 0 such that 5 minus root 3 is equal to A upon B. Now here we are going to shift to the left hand side. 5 minus A upon B is equal to root 3. Root 3 to the right hand side and A upon B to the left hand side. So it will be written as 5 minus A upon B is equal to root 3. Now here we will take the LCM. B, 5B minus A is equal to root 3. Now since A and B are integers, we get 5 minus A upon B is rational and root 3 is rational. But this contradicts the fact that root 3 is irrational. This contradiction has arisen because our incorrect assumption. So 5 minus root 3 is irrational. Now students, in this video there were two questions. It was root 2 and the second question was 5 minus root 3. So I hope you might have understood the concept. Now you will solve the assignment which you will get through your class teachers. Thank you.